So I'd like to thank everyone who's joining us today. Welcome to this CNCF webinar on understanding and deploying Kubernetes cloud security policies. I'm Mario Loria, your host. I'm a CNCF ambassador and a DevOps engineer at StockX. I'll be moderating the webinar. We'd like to welcome our presenter, Juanjo Carlente, a staff engineer at VMware. Just a couple housekeeping items before we start. During the webinar, you're not going to be able to talk as we have everyone muted, so Juanjo can present. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many as we can by the end. So we're going to give Juanjo about 45 minutes, and then we'll have 10 to 15 minutes for questions. So the session is being recorded and will be sent out afterward with a link to the presentation. Again, thank you very much for joining us. And with that, I'll hand it over to Juanjo to kick off.
Cool, thank you, Mario. Thanks, folks, for joining us. Indeed, I'm Juanjo. I work as a RE for Vietnam, now part of VMware. I work from the beautiful city of Mendoza, near the Andes in Argentina. So the purpose of this seminar is essentially to share our experience while deploying Kubernetes cloud security policies, indeed in our Vietnamese clusters. Main point being indeed sharing a pragmatic experience on our concerns and issues that we had while deploying them. So a bit of agenda. So we're going to cover why we need post security policies. We will show this in a very pragmatic way. How Kubernetes approach them, then how to implement it. This will be our particular take on how we did it at Vietnam. And then some considerations. So essentially, this will be kind of a mix between showing you the main points and actually going through a bit of demo-ish to show it. So essentially, the main thing behind this, if you can recall what you can do with Docker CLI, you may recall that you will be able to do something like Docker -- privileged and then running a container that has access to the node devices, or if you do -v, be able to mount any path into your container, or if you do -host = net, be able to use essentially the same networking as the node where your container will be running instead of on the own namespace. So the interesting thing about this, if you can create a pod in Kubernetes without post security policies in place, you can essentially do this in the node where your pod will be running. So this, at least for me, was quite shocking to see this behavior. It's clearly documented in Kubernetes if you hit that part of the documentation. But to actually get a bit of feeling of what you can do with this, I will show you what's there on the screen. I will show you actually on the command line, but just more or less to put us in context. So we start from using an account. This is actually a service account that has been enabled to be able to create any pod on a particular namespace, but only that. And then we'll see how we can use that ability, the ability to create a pod anywhere, to actually jump into the node and then land there at some node as root. Let's go over. So a bit of context here. So essentially, I created 2 clusters there. For what is worth, they're both running in GCP. One is GKE, like that cluster was created clicky to say, following GKE when you normally create a cluster without further customization. And the other one is a COPS cluster using the COPS tool that you can use to create clusters, your kind of customized clusters on AWS, GCE, DigitalOcean. In this case, I created the COPS cluster also in GCE just for convenience using the same account. So as you can see, I have there 2 clusters, and for contexts, these contexts, the first and the third context are actually cluster admin. And then I created, for both contexts, I created another one that has a simple service account whose only RBAC permissions that it has is to create a pod in its particular namespace, this one. So I will now flip over to use context. Let's flip to, I flip to that one. As you can see, if I ask myself with my current permissions to say, can I delete a node? No. Can I create cluster role binding that will allow me, for example, to assign myself my very SA cluster admin privileges? Nope. But I can create pods. So I will do that. Let me show you. Can I create pod in the namespace? Test simple. I do. Cool. So let's do that. I will go over and now just create it with this script. By the way, at the end of presentation, there will be a pointer to the slides and the repository with all these scripts that I'm using here. And we will go over this script also again during the presentation. So that's one of the COPS nodes. I'm there as root. As you can see, I essentially add the node. If I will change the just to show you that indeed I'm there. I just landed at the node. I can essentially, I'm there at the node. I can do whatever I want with the node. I will go further, and actually that was a worker node to say. I will go to the master node. So essentially what I'm doing here with this low privilege service account, I'm essentially landing there at the master. So I can then ask myself the same questions like, can I create cluster role binding? Of course, yes. Can I delete nodes? Yes. Let's go back and see what happened here. So essentially what I just did, this is an excerpt from the script I was just running. So what I just did, I did a normal kubectl run to create the pod normally, but then with some specific overrides, I asked myself to have a privileged container. I also requested to be able to use the same host PID namespace. And by means of this, by executing this very command, I was able to actually also use the namespace, the mount namespace, to actually land at the node. And all of this was possible essentially because I was just able to create a pod, and there was nothing blocking me for using this from using these particular fields to specify this kind of higher privileged features. So and here is what it comes. This can be easy to understand, because you can see the point of post security policy here. What we are trying to do here indeed is to apply policies to the fields that you can specify here. So essentially, policy is a list of these fields, these particular security sensitive fields, that you can actually say for example, I do not allow privileges to be specified for this certain set of pods. I also don't allow host PID, and so, or for example, in this case, I only allow these kind of volumes to be specified. By the way, what you have here middle screen is a snapshot from the post security policies page from the Kubernetes official info. But that's the main thing. The main thing is being able to actually apply policy and block anyone, or actually the set of security security accounts or users from specifying this. The thing is that you have this is the security policy, and then you need to be able to associate, because usually in a running cluster, as you can imagine, you may have a handful of security policies. You may have some workloads that need to be privileged. Typically, those workloads running, for example, in the kube system. Other workloads that may be not prepared to run as non-root, so you may actually want to allow them running as root, containers are root. But for these particular workloads, you may also want to limit not to be able to mount pieces of the node host path into the container. So the thing is that how do you associate your workloads with this particular post security policies? And the answer, as you may already guess, is RBAC. RBAC is a generic mechanism from Kubernetes to do this, where you essentially, if you recall RBAC, you have these role bindings that actually point to a role. So role binding, it says who can, and then the role lists all the things that these subjects will be able to do once bound to this role. As you can see there in the slide, role binding is who can, and the role is do what on those resources. So in this particular case, for example, we have this user Joe, that actually is able to use the dev role, and the dev role allows him to create and get config maps. And we're going to use this also for PSPs, but here comes the twist. The thing is that for PSPs, as you can see for normal RBAC, the endpoint for the specification of the set of permissions of the ACL that you can do ends up in the role. So the role contains the policy to say. As you can see, the role says you can do this or that against these particular resources. The kind of extra complication with PSPs arises from the fact that there are actually a third level of indirection. For example, here you have the same user that we say, okay, you can use this privileged role, and actually it's non-privileged because it's privileged false, but you can use this priv role that points to this particular role, and then the role is not as, I would say, as rich as the normal RBAC role, but usually these roles are very small, and they just say things like, for example, you can use this particular PSP and then point to the PSP. And it's the PSP who has all these fields that I showed you a couple of slides before, when you can say, this, you are allowed to do this, you are not allowed to do that. This is a very important thing to keep in mind, because it complicates matters when you need to actually write your manifests for these policies. It's important to keep this in mind, this kind of third level of indirection, that the policy is actually specifying the PSP itself, and the role itself is just kind of also kind of a binding mechanism between the subject and the final PSP that you will be using. Then you have the issue that you will, normally naming is hard, as we already know, and then you will have to find names for your role bindings, find names for your roles, find names for your post security policies, and there it comes the complication, especially when you're trying to deploy them. I will go over and let's see this. Let's put this in practice just with this overview. So what I'm going to do here, I'm going to enable PSP. So essentially, when you use PSPs, post security policies, usually you manifest them. So you create YAMLs in a very Kubernetes way. When you create YAMLs to specify these policies, you upload them to the API. So essentially, you apply these policies, post security policies. It's important to keep in mind that post security policies themselves are implemented via an admission controller by the Kubernetes API. And once you enable that admission controller, essentially will allow nothing unless it has a security policy that opens the set of permissions to be able for the workload to run. So usually the workflow is you first need to apply the PSPs even without enabling them at the API endpoint, and then enable them at the API. Back to our context, recall that we are here at my COPS cluster with this low privileged account. I'm going now to log into on my Kubernetes endpoint API. This is essentially the master, the same place where we arrived before, but doing this non-xamptum way to arrive there. And I'm going to manually edit the Kubernetes API manifest. By the way, normally COPS, if you see the COPS documentation, you have a formal way to do this. The proper way to do this will be to actually modify your KubeCon manifest, say there that you want to enable this pod security, this new admission controller, and then do a rollout. Just to go over here, and for clarity, I'm going to do this manually. Usually you won't do this in a production cluster because this will be overridden, for example, if the master node is replaced. What we are seeing here essentially is a YAML manifest for the pod that runs the Kube API endpoint. And if you search here for a mission controller, you will see this is the normal line for our mission controller. This is the fault that comes with COPS. I will just add here post security policy as another emission controller. This is not pretending to be a lesson on how to enable it, but just to show the effect. This is something important I wanted to show you while running them. So I have already uploaded my set of PSPs. I just enable them. If I do, for example, psfax grep sec, sorry, sec, oh, there. Without O this time. There we go. So essentially we have there the container that is handled by the kubelet, and then of course we are running with this new emission controller there. Okay, let's see how this looks. I cannot get pod on all namespaces because I'm using indeed this low privilege account. I'm going to now switch to my cluster admin that I have for this cluster. As you can see, I have there kind of a mostly unloaded cluster. I had created some workloads there that you see here, NS main root, non-root, and restricted. I already uploaded some PSPs. I will go over this set of PSPs in a moment. But I wanted to show you how this looks if first thing to note here, I just enabled pod security policies, but you can see that no pod was affected by this because they are more or less, in general, the PSP will be actually evaluated at the pod creation time. So what I'm going to do here is kick this all these pods that are running these specific namespaces, these particular namespaces, and see the result of it. As you can see, they're not running anymore. So just to comment a bit about these particular namespaces, more or less the name is self-informative. So on this namespace, you may actually run your workloads at root. You are not allowed to do privileged or do host mounts. This is strict non-root, and this is more restricted. So it's not only the non-root, but also in our particular choose of these security policies, we are also restricting the file system to be read-only. So let's see some of the errors here. If you see, for example, main root, I'm running their Nginx stock container from Nginx stock image, this one. Then I'm running one that is built by Bitnami, that is non-root by default. So, and you can see, for example, that is in this particular namespace that has the policy or that it needs to be non-root workloads. You can see that the Bitnami Nginx is running fine, but then the stock has failed to actually create the container. Let's see what is telling about it. This is normal stuff that you already know. Describe pod-n non-root for Nginx stock. And then, as you can see, the policy was applied just before creating the container. So the container needs to be run as non-root, and then, sorry, the policy says run as non-root, but the image will still run as root. Let's see what happened there with the NS restricted namespace. As you can see, this will be evidently the same because essentially it has the same constraints. But in the case of this container, it's actually doing crash loop back off. So essentially it's erroring and retrying. So in this case, let's go over the logs just to see what is going on there. And you can see there that the instrumentation of this container, of this image, when it starts, it wants to create a file there, and it cannot, and then it fails. So this is just a quick view of the kind of issues that you may get when you actually flip and enable the post-security policies. Just to show you the complete picture and try to exploit this, I'm going to, as I did before, I'm going to switch over to this low non-privileged security, sorry, SA, and try to exploit it again by using the same script. And then you can see I cannot do in particular host is actually bombing from on the host network and asking for the host network. But if I try to comment out these fields, I will still hit some point when I want to have privileges. And so I also had prepared there, you will see a script that does not, let's see, it doesn't require privileges, but actually is trying to abuse this by doing a volume mount of bar run, and then once it's able to mount bar run, trying to do a Docker command inside the very Docker to try to, this kind of running Docker inside the very container to try to go over the same command that I did before. It actually works. But if I try to do this, now you see that it will fail because I'm not being able to actually use that volume type that is host path. So now switching over to our actual experience while trying to deploy this in our dynamic clusters. As I was telling before, naming is a key here from several aspects. One is not going mad on the naming that you've used it, because you will need to, in particular, you will need to find names for PSPs. PSPs are sensitive to sort order. The thing is that, and this is something very important to keep in mind, you cannot attach several PSPs to a pod via RBAC. Normal RBAC, you have a subject that can do several things, and then you can kind of aggregate the things via different role bindings to be able to expand the permissions that the particular subject can do. But in the case of PSP, there is a single final PSP that is selected, and that final PSP, in case you had several ones possible, for example, from a cluster-wide role binding, and then a particular role binding applied to the namespace, they will get sorted, and the first one in sort order will be selected. That's why it's ordered in this way, from more restricted to less restrictive. In our particular case, because of the kind of workloads that we are using, we ended up crafting one that we call may root. As you can see, that actually the container may run as root, but obviously without any privilege and without being able to directly use host resources like mount pass and so. And then we created these other policies that are more restricted. We created also privileges that were using explicitly and only in the kube system namespace and other namespace, kubeprod. This comes actually from the BKR project where we run our monitoring and logging. But this is very important, and also to kind of tie all these together so that the cluster role binding points to the proper cluster role and then points to the PSP. Let me show you how we did this. I have a few, let me see. Yeah, I have some few minutes. So I want to show you how we actually instrumented this. We are fans of using JSONet for our manifests. I know that JSONet sometimes can be a beast has a kind of steep learning curve. But let me show you how more or less how this. These are actual excerpts from our very implementation that we did in our clusters. So remind that. Sorry, I pressed the wrong key here. So what we want to keep more or less same is all the time in on all of these rows, so that it's easier for me as I write my manifest of the PSPs to maintain these rows same. And let's say now that because I just changed the name of some particular cluster row because now it needs to cope with different scope, I need to rename this cluster role of the PSP. I need to grep for all the places where I point to it. But actually, to avoid doing that, then we can use this kind of high, we can use JSON to actually tie all this together. Let me show you quickly how is this implemented. For example, this is pretty much readable. So essentially, this will just create a manifest for a PSP. We created a mini library there, just order PSP, that will essentially put 80-privileged as the name of the PSP. And here we declare what we do. As privileged, this is the PSP that we reserve for the kind of system workloads. The nice thing about this construction is that you can derive from it. For example, you have here main root. That main root is actually derives from privileged, has a different name. It will be 60-main root, but it has all these bits forbidden. So essentially, you are not just as the privileged, but without being privileged, without allowing privilege escalations. This is essentially pseudo, allowing the container to do pseudo, and then not allowing any of these host resources. We already defined what we think that are safe volumes. This comes from the general documentation. And then, as you can see, we can go then over and say non-root derives from main root, but that actually puts all these additional additional restrictions on it, and then restricted as over. The nice thing about this is that with a bit of instrumentation, I'm going to show you. Essentially, from this set of PSPs, we can create this full tree of manifests. You can see there the ones that are called PSP CR as for cluster rows. This is cluster row binding. In particular, as I mentioned, we have a single cluster row binding that we selected for a particular use case that we chose based on exploring our workloads. And as you can see, this is main root. And then we have there all the cluster roles. The cluster roles do map 1-to-1 with the PSPs that we are using. So you will see here the cluster roles and here the PSPs. There is some interesting note about this. I will talk in a bit about this PKS restricted and OpenShift restricted. And then we are applying particular PSP role bindings to particular namespaces where we want them to be privileged. Going back to the JSONet, we found that in Vietnam in particular, we also prepare containers to be able to run in OpenShift platforms. OpenShift has a different take on security. It's not strictly PSP, they call it SCC. I don't recall now exactly what I mean, but essentially are more or less the same. So we're trying to mimic here what the default OpenShift policy will be, so that our developers are able to actually run in a particular namespace in a non-OpenShift cluster with more or less the same constraints to essentially to validate that our containers are running fine there. And in a similar way, but this is more Kubernetes, stock Kubernetes, PKS comes from Pivotal cluster, Kubernetes cluster offer. So, and the difference with our definition of restricted is that PKS actually does not force the read-only file system, so that's why it's false. Besides the instrumentation, this is the result. Let me just show you how I crafted this. So essentially, we have here these two files. These are kind of library files that define the common ground for clusters. And then let's say that this is my cluster 01, C01. And then I have here a particular case for this cluster. And this is actually what we did with our clusters. We went over, and then for some cluster, for example, we're using Jenkins Docker in Docker. So this Jenkins actually creates Docker containers to run as slates, or to bounce them and then run other slates at the cloud platform, but actually needs to create these DND workloads. And they did need to run as privileged. So we went over and say, for example, we say for the Jenkins team foo, they need to, you can see here, they need to run as privileged. And then we, for example, for this particular namespace that we want to actually do the test bed of our OpenShift workloads, we allow them to do so. What I'm going to do here now, just to show you the effect from the outside, you can see here, this is a clean Git repo. I'm committing both the source and the generated files. So I'm going to, indeed, I did a change there just to allow those namespaces. I'm going to rerun make. And then, as you can see here, you will have two new manifests. And the nice thing about this instrumentation is that it's all tied together without errors. I mean, I just needed to do in JSON source code to properly point to the variable name. So if I miss the variable name, the JSON won't actually be able to manifest, and will fail by telling me something like that variable does not exist, that field does not exist. So it's kind of a, let's say, compile time check rather than runtime check, where you actually miss it by a character pointing your role binding to your actual PSP.
Hey, Juanjo, just want to give you a 10-minute warning, and then we'll get to questions. Thank you.
Thank you. Thanks, Mario. Yeah, I think we are fine time-wise. So in general, from our real-world considerations while trying to deploy this, while not trying, actually, we did deploy this to all our cluster running with PSP enabled. There is important to note that pods won't be run usually by humans, but actually by service accounts. So that means that humans or CI/CDs, like Jenkins, for example, will actually be creating deployments, or will be creating stateful sets rather than pods directly. So the binding between what is the who that will be running your workload will be the service account that needs to actually bind to a particular PSP. This is important to note, and it's very well documented elsewhere. We also use the kubePSP advisor tool. There is very, very useful. You can run in cluster-wide, or you can run it again namespaces. What we did there, we actually kind of grouped all together namespaces that we knew that were kind of particular different. For example, kube system being a very particular case, the namespaces where our Jenkinses are running, the namespaces are kind of, between quotes, more normal workloads. We ran this tool, and then we did a diff to actually spot what were the fields that we need to highlight, we need to actually set or unset in our PSPs to try to narrow the set of PSPs to the bare minimum. Keep in mind, again, now this is quite important. This is not to diminish the amount of time that you need to invest on this, because PSPs are not aggregatable. If you think of the combinatory there, let's say, roughly speaking, you have, let's say, 10 fields that are of your interest that can be Boolean, 10 Boolean fields that will give you something like 1,000 of possible combinations there. So it's very important to try to group all your set of workloads that you can frame them under the same PSP, and then try to come out with a handful of PSPs. Also important is to try to, once you have this view, to try to come out with a default cluster-wide PSP so that you actually do the particular case for the namespaces that you need to indeed do this particular case on. Like, for example, in our case, as I mentioned, going back a bit, we are using this one, this main root one, because this copes with most of our workloads. And then for these particular namespaces, we are actually allowing them privileges. And then we're experimenting with other namespaces and trying to move over here that is more restricting even more our workloads. As I mentioned, you have to be really careful with ordering, because most errors here come with this fact. Keep in mind, think role binding, think cluster role binding and role binding. And then when you have a workload, you need to think of all the possible bindings that it has, and then find out the PSPs that are behind it, and then order them. And then the first one that comes out will be the ones that you will be actually using. So this is pretty important. And as always, you need to, this is a DevOption, like all the DevOps, both the SREs and your developers need to be engaged on actually building the PSPs and understanding them. You need to also, as I quickly saw, as I quickly demo you, I didn't show how to upload the PSP because it's boring as usual, like kubectl apply-f, and then you have, for example, a folder there when you have all your PSPs, and then it will be applied to the API. But the thing here, this sequence, like applying your PSPs, and then later enabling the post security policy in the Kube API. This is platform dependent. You really need to know how to use your platform. This thing that I kick, when I kicked those pods to see them failing, is what I mentioned here as recycle your pods under control, because essentially nothing will happen once you enable your post security policy admission controller and your Kube API. But it will happen when you try to create the pods. So of course you don't want to have surprises that are not under your timely control. So and this is also where you need to involve your developer teams to actually do this recycling of your pods in a controlled way. Oh yeah, and some scriptery there that I also, you will find also in this repo. In particular, I found very interesting that there is a metadata, there's an annotation that is this annotation that it will be added by the API to all of the pods. Let me show you how it looks. I will need to actually resize the screen a bit, but let me show you. Of course, I'm no one. So let's switch to my cluster admin. There you have. So essentially, this is just a script that is abusing the JSON path facility there in kubectl to show which, as you can see, this pod has this particular PSP attached. Here we can enforce that there is a single PSP that will be attached to each pod. There is no multi-PSP. And then you can see some other interesting things here. Like, for example, I didn't cycle these other pods. As you can see, they're running without PSP. Next time they are cycled, they will actually get attached to the PSP. So it's important while you deploy to actually keep observing how these PSPs are attached, especially to assert that the expected PSP is attached in the proper namespaces and to the proper service accounts. And some final references that we found useful. So here you find reference to this very set of slides, and then the repo. I guess Mario, we can later put this here as a comment when we upload the video to YouTube. The reference to these slides and the repo. So you obviously then you can follow up from there with these other good reads.
Yep, absolutely. Awesome. Thank you so much, Juanjo, for the really great presentation. We now have some time for questions, about 10 to 15 minutes. If you have a question you'd like to ask, there's a little QA button at the bottom of your Zoom window. click that and go ahead and ask away. We'll only be able to get to a certain number of questions that time allows. So if we don't get to your question, don't worry, you'll be able to reach out and we'll give you details on that here in a minute. So I'm going to go through here and try to get to some of these questions. Please try to keep your questions kind of short and micro-sized so we can easily get to them and Juanjo can hit them quickly. So let's get to the first one from Suraj. Static pods are created by kubelet, but it also creates mirror pods on API server. But if a kubelet has no access to a PSP, the mirror pod won't be created. What PSP is tied to the kubelet user?
Oh, that's very good question. Thanks for that. Let me show you. So we were careful on. Let me show you how we did that. Indeed, there is the kind of system warlocks do have their own secure service accounts, these ones, so that are characterized by group. So I didn't mention, but essentially all service accounts are under this particular group. So you have these other groups that are system : something, and then you can see there that in our implementation we actually tie them as they are running the kube system. We tie them to be able to actually use the same PSP. This is how we tackled that.
Awesome. Let's go to the next one from Jan. Can you use customize instead of ksonnet/jsonnet to create permutations of policies?
Yeah, of course. We chose JSONet because we are accustomed to use it, but nothing really forbids you from using customize. Let me think. I haven't used it much customized. I have tried the kind of hello world-ish example. You can do all these overrides. My only concern there will be the kind of sanity when it comes to trying to keep this table, whatever take on your own table you do on this, like trying to associate all these three names all together without missing a character there. We really like, as I mentioned, the fact that you point here to variable names, like in this one, rather than needing to match a particular set of characters. I don't know how Customize will handle that. Certainly you can. I don't know if it will help you on at compile time to say, or before actually applying them, that you're not mishandling them. I really don't know.
Great, thank you. Are the JSON examples in a Git repository?
Yeah, of course. Everything will be on the Git repository. All the JSONet and this small make file also. Yeah.
Yep. And again, we'll have the recording out momentarily after this presentation's over. From Aaron, where would you recommend putting security resource declarations when using Helm charts? Should it go into the chart, into a dependency chart, a parallel chart, or somewhere else entirely?
Very good question. It will. Whoa. Oh, it's a question that have several aspects. The first one is Helm v2 or v3? Because are you using cluster admin or not? Because let's put it from a different point of view. The deployment of the PSPs themselves, we are handling it with cluster admin privileges, the PSPs themselves. So usually, the thing is that if the entity deploying the Helm chart does have cluster admin, this is kind of a normal assumption under Helm v2, then you would be able to actually put there the PSP that you want to use. Because you are cluster admin, you will be able to actually create the PSP, the non-spaced PSP, create the roles, and potentially, the cluster roles and maybe the role binding. But that's not the take that's not the path I will follow. I will try to keep PSP and the PSPs under the control of the general, more close to the general cluster setup, more close to the cluster admin, and indeed be able to actually spot Helm charts that will actually go over and potentially harm the cluster. So I will keep it out of the Helm charts unless they are your own crafted Helm charts, I would say, because indeed this is I find it as a good measure, because you're protecting yourself to potentially harmful Helm charts. So in summary, I will still try to keep it out of the Helm charts unless it was a specific Helm charts implementing PSPs. Let's say a dedicated Helm charts to ease your PSP implementation that will be actually deployed by the cluster admin itself, but not together with the workloads, not for Helm charts manifesting user workloads, to say.
Great. Yeah, great. Thank you. Let's see. We have a question from Anoop. Are you saying that setting up of service accounts is not particularly secure? Why do we have to use RBAC with the service accounts? Are they not secure by default?
Let me try to, correct me if I didn't get properly the question, but essentially, yeah, when you create a service account, it will be kind of, let's say, between quotes, a naked subject there in the cluster that can't do anything. By RBAC, you will be actually binding it to roles to open the permissions or open the access to be able to do full one bar. From that point of view, PSP are not different from RBAC from the point of view that you have your service account that you will declare in your own pod that will be running the subject that you will be running your pod. And then with RBAC, you actually will allow that service account in this particular concept of PSP to do that, this and that. The thing is that if you, let's say that you, let me reframe this in a different way. Let's say that you actually enable the admission controller. Let's say that you took care of putting the PSP for your non-workloads. If you put there a naked service account that will be only able to create pods, for example, to actually create the pods, and does not have a PSP attached, it will essentially fail. So you will need to, if you have PSP enabled in the cluster, you will need to bind it to some PSP to be able to do anything. And that's why we kind of, it's important to choose this kind of cluster-wide default that we did with this main route. But please correct me if I didn't answer your question, or maybe you can follow up with us at the Kubernetes channel. Sorry, Kubernetes Slack.
Yep, absolutely. And I think Juanjo, as well as many other engineers from VMware, hang out in Slack as well. So let's get to the next question. Is this used by public cloud providers such as Google Kubernetes Service, Amazon, etc.?
Oh, that's a very interesting question indeed. And that's why I had these two clusters set up. Let me get back in context, literally. So this is the context. I have these two clusters. I had deployed a COPS cluster manually and then a GKE cluster. I will switch now to the GKE cluster. Use context, and let's use GKE simple essay. Just to show you that this is not really exploited because it's all there documented. This kind of ability to overcome this and land there as a node. As you can see, this is one of the GKE nodes there. I'm there at the node. I was there before with a low privilege account. So the thing is that it's not enabled by default in this. If you search, for example, in the case of GKE, indeed it's a beta. It's a beta feature. You just search for GKE PSP, and you will find a very nice page. Indeed, we have some GKE cluster, and we did that. We did something like G-Cloud containers beta enable PSP, just to put it in easy. But you have the specific steps, and essentially that conveys the flipping the PSP at the Kubernetes API endpoint, of course. Of course, you will still need to do the preparation of your PSPs as you do for any clusters. For other platforms, I honestly don't know. I will need to search. I'm sure about GKE in particular because we're using them. And of course, if you run one yourself, you can just modify the API endpoint.
Awesome. Thank you, sir. And let's get on to the next question. What is the default behavior if PSP is enabled with no policies defined?
It will essentially, you are not allowing the pod to do anything. So I wonder if a pod does have a read-only file system, does not run as root, of course, non-privileged, no non-volume, nothing. It's a very good question, and I honestly don't know the answer. I will need to test it. But let's say that will be an image that is a true, very well-crafted image that is not trying to use any kind of extra functionality. It may be able to run. I really don't know the answer. That's thanks for that. I will actually try it.
For sure.
Maybe,
yeah, that's a great question. From Darwin, how many different PSPs are you using in production? How many in dev? Asking kind of production versus development experiences and differences.
Thanks for the question. Very good question indeed. So essentially, because we try to make our development cluster as close to production as possible, just to not get these kind of surprises when you go to production. What we settle is on having the same PSPs, that is the very set of PSPs, all the same in every cluster, like dev, staging, and production. So there, when we need to create a new PSP, maybe specific to that workload, we actually deploy them to all our clusters. And then based on the particular environment, we will actually do the role binding specific per cluster. Because maybe in one namespace is named foo, and in other cluster is named differently. But essentially what we try to do is try to keep the same set of PSPs. Actually, we are now using we settle into 6-7 PSPs on particular cases where we're running this default, and then we have 4 or 5 particular cases, more or less the one that I depicted there in the slides, like for the Jenkinses and for some other workloads that need to have a bit of expanded main root. I don't recall now what field we had to add, but essentially kind of a handful-ish as role bindings, and maybe about 8 PSPs in total.
Gotcha, great. Let's see, from Vaishak, are PSPs only applicable at pod creation time? What happens if I do a change to the policy, like dropping allow host network? What happens to the existing pods?
They were, as far as I understand from the documentation and my experience, indeed, they won't be affected. Actually, the documentation is a bit tricky there because it says something like, it won't, so you apply PSPs, nothing will happen indeed. And the documentation mentions something like update time, an update action, that is an update verb to a pod definition, won't be affected by PSP, but will be evaluated at creation time. There is some small wording there that I'm not sure I fully understand. The part of the documentation on this particular behavior on the Kubernetes official doc could be improved a bit, but it's my understanding and my experience that indeed they are not affected, and they will be indeed impacted when the pod gets recreated.
Awesome. Okay, just a couple more questions here and then we'll wrap it up. Let's see. Can I have different PSPs for different pods in a cluster?
Yeah, of course. It just that's for sure. Our take to kind of simplify and now go mad on this. Our take on this was essentially to frame them as per namespace, to say. So what our take there is actually to say, okay, for this namespace, you will get bound to this particular PSP, because so then put all these workloads in this very namespace that will get attached to this very same PSP. But nothing forbids you to be more specific, and maybe in the same very namespace, you say, when you, in this namespace, but if you use this different service account that is not the default service account for the namespace, the service account that is named foo_bar, it will get attached to this particular PSP. So that's how you actually, in a very RBAC way, you actually discriminate by being more specific on the service account binding to that particular PSP. It's not bound to the PSP, but actually it's bound to the role that then points to the PSP.
Awesome, great answer. One last question from Jeremy. When a pod violates a PSP, what gets logged to the Kubernetes audit logs?
Oh, I didn't try that, honestly. I was, because we don't have audit logs enabled in, that's a very good question. I don't have the answer. I did note that there was nothing on the Kubernetes API logs themselves, because I was trying to, we are doing some log aggregation there. I was trying to find out if the Kube API logs, not the audit log, but the Kube API logs, the raw logs to say, were saying something about these violations, and didn't find any. But I didn't explore the audits. We don't have them enabled because, yeah.
No problem. Yeah,
take a note of it. Yeah, that's very good question.
Yeah, that's a good question, definitely. And Jeremy, I'm sure you can follow up with Juanjo in the Kubernetes Slack. Actually, so that's all for questions that we have for now. Thank you to Juanjo for answering all those to the best of his abilities. If we did not get to your question, you can reach out to the Bitnami team at VMware via kubernetes@bitnami.com, or reach out to them in the public Kubernetes Slack network. Hopefully all of you are in there already. And I want to thank Juanjo and all of our great guests for coming on. That is all from us for now. Thanks for joining us. The webinar recording and slides will be online later today, so keep your eyes peeled. And we look forward to seeing you at a future CNCF webinar. Thanks a lot for joining, and have a great day.
Thanks, Mario, and thanks to CNCF for helping us with this. Thank you.
Absolutely.